Okay, so our first section here is on transformations. Most schools, I think, across the province often start with transformations. And the reason we like to start with transformations is because it permeates into every other unit that we do, okay? I have tutored some kids that they start with function ops or something like that. But for the most part, I think, most teachers like to start with transformations. Okay, so the way each kind of section is set up is I'm going to run you through some notes, just kind of the big picture. These are kind of the things you need to know in this unit, and then we'll work through class examples together, okay? So the class examples that we work through together, there is no answer key in your book for because we're going to do them together and you'll have them here on the video. But then at the end of each section, there'll be an extra practice section. That's meant to just give you resources to be trying on your own. And you will find answer keys to all of those right at the back of each of the extra practice sections, okay? The extra practice section will end with the answer key so you can check your work, okay? Okay, so transformations refer to changing an object through translations, which are slides, reflections, which is flipping, and rotations. For a function y equals f of x. Now, y equals f of x, that's just kind of the general way we say, hey, this is going to be the starting function that we deal with before we do any transformations, okay? Transformations can be described using the following transformation equation. Now, this equation is on your formula sheet. It might have square brackets as the bigger set of brackets there, but it doesn't really matter. What I want you to notice is we've taken y equals f of x and we've added in 4 different parameters, the a, the b, the h, and the k. And at this stage, I'm hoping you're decently comfortable with what each of those guys is. So your a is a vertical stretch by a factor of a about the x-axis, okay? Remember, when we do a vertical stretch, it's about the x-axis. If I was to show you a coordinate plane here, if I stretch this vertically, I'm going like that, right? Well, what doesn't change there, the x-axis is what's not changing, okay? Same with a vertical reflection, right? If I do a vertical reflection, the visual in your head is super, super important, okay? If I do a vertical reflection like that, I'm doing it against the x-axis. So when you're describing these transformations, you need to put all those pieces together, okay? So A would be a vertical stretch of A, we say by a factor of a about the x-axis, and then if a was negative, sorry, it would also be a reflection about the x-axis. Okay. Now your b value, the b value is a horizontal stretch of 1 over b, and now that's about the y-axis, right? If I do a horizontal stretch like that, okay, that would be against the y-axis, and same with if b is negative. It would be a horizontal reflection, okay? So I have absolute value brackets there just to say, like, we would never say I have a stretch of -3, okay? I have a stretch of 3 and then I have a reflection, but you never call a stretch negative. As soon as you see that negative sign, then you're talking about a reflection. It's gonna be a separate statement, okay? So that's just why I put the A and the 1 over B there in bracket, or sorry, absolute brackets, the absolute value brackets. I couldn't get that word out, sorry. I put them there to say, you're not ever gonna tell me a negative there. The negative would be in with the reflection, okay? Then we have H. H is our horizontal translation. If H is positive, I'm going to the right, and if H is negative, I'm going to the left. Now, we need to have a quick conversation about this because this always confuses kids. If I see, let's go y equals f of x minus 5, okay? If I ask you what the value of h is there, the value of h is +5, because in my equation, it says x minus whatever h is, okay? So when it says x minus h like that, h is right here. It has to be x subtract whatever h is. So if this says x subtract 5, h itself is +5, okay? And so h is 5, and I'm heading to the right, 5 units, okay? If this said x plus 3, well, the only reason that could have said x plus 3, if I have to think about this as a subtraction statement, is it must have at one point said x minus -3, in order to get that subtraction there. And then those two negatives made that positive, right? So what's the value of h? The value of h is -3, okay? So when I say h is positive and h is negative, I'm not talking about what it looks like in the equation. I'm talking about what the actual value is. And that's really an important distinction, okay? Because your diploma will often say h is greater than 0 or h is less than 0. That doesn't mean inside the equation. You have to interpret that properly, okay? So if h is negative, I'm heading to the left. And if h is positive, I'm heading to the right. And then k would be my vertical translation. And if k is positive, I'm heading up. And if k is negative, I'm heading down. Okay? All right, then we also dealt with diagonal reflections. Diagonal reflections can also occur, and that would be against the line y equals x, which is essentially kind of the 45-degree line on the coordinate plane. So that would look something like this. And you'd have the point there, 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, -1, -1, -2, -2, blah, 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 okay? This also results in an inverse. An inverse can be denoted as x equals f of y, or as y equals f to the -1 of x on your diploma. This guy here is usually reserved for if the inverse is a function, okay? So we only see that f to the -1 if the inverse is a function. Okay, I didn't read my own notes. The latter notation is usually reserved for if the inverse is also a function. Sorry, I just got talking. Okay, now, graphically, we can switch the x and y coordinates and plot, okay? Algebraically, we switch the x and y values, and then we isolate for y. We can also do it with technology. Now, as we go through this whole session together, this 14 hours together, I will give you some calculator tricks along the way. You know, your diploma is not far away, and my intent with the calculator is not to stress you out. Some of you are going to be very bent to technology, and some of you are going to pick up on some of these things really easy. If you're a person that a new way of doing something in your calculator causes stress, then ignore those, okay? Do it the way you've done it. It's just sometimes it's nice to be able to check things in our calculator to make sure what we think our understanding is actually correct, okay? So if you wanted to draw a quick sketch, if you had something in your Y1 of your graphing calculator, on a Casio, you can sketch the inverse just by pressing F4, F4. And on a TI, you can sketch the inverse if you press those commands. So second program, the number 8, go into variable, Y variable, 1, 1, and enter, and that will allow you to sketch the inverse. Now, both of these guys, that will give you a picture of whatever your Y1 graph was. It'll give you a superimposed picture of the inverse, okay? It's useful if you're not quite sure what the inverse would look like in your head, but you can't trace it. It's not an actual equation, so you can't do any of the kind of graphing calculator calculations with it. You couldn't find the x-intercept, or you couldn't find the intersection of the two lines or anything like that. It's just kind of a picture on top of the graph to show you what it would look like, okay? But it's a helpful visual if you needed a helpful visual, okay? Oh, sorry, I just need to take my ink off. Okay, transformations are always described in a particular order, and that order is we got to deal with stretches, then reflections, then translations. Personally, if I ask you to describe transformations, I would also inside that want you to do horizontal before vertical whenever possible. So like say you had all 6 items, you would want to go list the horizontal stretch and then the vertical stretch, and then the horizontal reflection and then the vertical reflection, and then the horizontal translation and the vertical translation. Be very careful. I don't know who your teacher was. Lots of teachers will allow you to write, for instance, HT, and HT means horizontal translation, okay? You can't do that on your diploma. If it's a written response question, abbreviations will not be accepted at all, okay? When we're marking diplomas, we look at HT and we say, what does HT mean? HT could mean high top. HT could mean hot temperature. I'm just trying to quickly pick up things off the top of my head. But so the point is, don't use any abbreviations, okay? Okay, so we'll do some practice questions together. We've got number 1, the following represents transformations on the function y equals f of x. Describe the transformation. So most of us probably want to write this in terms of y first. So we're just going to bring that -3 over and call it a +3. And that would look like y equals negative f of x plus 3. So there are two statements you would want to make here. By the way, just so that you're getting into the groove as you go through these videos by yourself, you want to, like, I'm not going to give you time to write things down. So what you want to do is when you have a question like this, you want to pause me and then you do it and then come back and see the answer, okay? So there are two statements that you should have made on this one. You've got a vertical reflection about the x-axis and then a vertical translation 3 units up. Okay, so the vertical reflection was from my negative side and the translation 3 units up was from my k value of +3. Okay, next guy, we're going to get a little harder as we go. So again, we're trying to represent the transformations, describe them. There are several things I need you to see here. Number one, I need you to see that this is not in factored form. I absolutely promise you, your diploma is going to test you on this, okay? They're going to test whether you realize that you can't read the transformations unless they're in factored form. So the very first thing you're going to do here is you're going to factor that -2 out of the -2x and the 2. Okay, the other thing you're going to have to do is you're going to have to bring that 1 over and it's going to become -1 on this side. Okay, but then you also have to divide everything by -1. Now, when you go to divide everything by -1, this guy is another term. He also has to be divided by -1. It's important that you're not breaking kind of the grade 9 algebra rules that you have come to know, okay? I always tell my 30-1 kids, what usually messes you up in a 30-1 question is not your understanding of 30-1. Most of you are going to have a nice deep level understanding of 30-1, but we make these little grade 9 algebra mistakes along the way, and that's what you have to be super careful of, okay? So you notice that this whole thing is one term, okay? And then this is a second term, so you can't forget that second term. So when we clean all of that up, you should be looking at something like this, okay? And then we want to describe the transformation. So we've got 1, 2, 3, 4, 5 different statements that you should have written. Okay, and the 5 different statements are your horizontal stretch by a factor of 1/2 about the y-axis. So again, I want you just to take note of the specificity of how I'm speaking, okay? I've said it was horizontal. I've said it was a stretch. I said what the factor was, and I said what it was about. Those are all things that you have to communicate well. Okay, then we have a horizontal reflection about the y-axis, a vertical reflection about the x-axis, and a horizontal translation 1 unit right and a vertical translation 1 unit up. Okay, so invariant points. Invariant points are those that remained unchanged after a transformation occur. So they're always going to happen on your mirror line. So if you're doing a reflection, okay, the line of reflection, or if you're doing a stretch, the line of stretch, but the line of stretch and the mirror line are really the same thing, okay? For combinations of vertical and horizontal reflections and stretches. So say you had a vertical stretch with a horizontal reflection, okay? For most of that, your invariant points don't exist anymore because your vertical invariant points get undone by the horizontal item and your horizontal invariant points get undone by the vertical item. The only thing that wouldn't change if you have both vertical and horizontal going on would be the origin, which is 0, 0. So if you have both vertical and horizontal items happening, look for whether the graph exists at the origin. If the graph exists at the origin, you'd have 1 invariant point. If the graph doesn't exist at the origin, you'd have no invariant points, okay? And then for translations, there are no invariant points. As soon as you slide something to the left or to the right, you've slid everything to the left or to the right or up or down. And that means everything changed. So the definition of an invariant point is it didn't change, so that doesn't happen with translations. Okay, this is a very common numeric response sort of a question. Okay, I see a question like this a lot on your diploma. So the following represents the function y equals f of x. For each of the transformations below, determine the number of invariant points. So you're looking at this table below and you're thinking, okay, well, what am I doing? That very first one is y equals negative f of x. So that's a vertical reflection. If I do a vertical reflection there, what doesn't change? Well, anything on the x-axis doesn't change. There are 3 x-intercepts there, so there would be 3 let's just put that in for a sec. There would be 3 invariant points there. Okay, the next guy, I've got f of negative x, so that's a horizontal reflection. If I do a horizontal reflection, my invariant points lie on the mirror line, which would be the y-axis, and there'd be 1 there. Okay, for the x equals f of y, please, please, please always draw that line in, okay? Always get the proper visual there. So here I am putting that line in, and I'm just looking for the point 1, 1, 2, 2, 3, 3. Any intersection with that line, whether you can see it nicely or not, any intersection with that line would be an invariant point, okay? So it's always better to draw that line in, okay? Now these ones were nice points. You can tell it's -1, -1, and you can tell it's 4, 4. But often kids get thrown off if like the invariant point is not something they can read, like 4.267 and 4.267. Just because you don't know exactly what it is doesn't mean it's not there. That's why I'm saying look for the intersection points, okay? So there'd be 2 for that guy. And then negative f of negative x, I'm doing both a horizontal and a vertical reflection. If I'm doing both a horizontal and a vertical reflection, the only possibility for an invariant point is at the origin, and there is no point at the origin, so there would be no invariant points. Okay, so 3, 2, or sorry, 3, 1, 2, and 0. 3, 1, 2, and 0. Okay. All right, the general equation of the image point or mapping rules are a way to figure out where one point will end up after a transformation has occurred. So when graphing, this is the easiest way to do multiple transformations. Come up with that mapping rule, come up with that general equation of the image point, and then you can apply all your points from your original graph into the mapping rule and get the new points for your transformed graph. Mapping rules are always read exactly like the transformation is. The only interpretation you ever need to make is when you're dealing with transformation equations. So if you see 1/2 x, so x maps to 1/2 x type thing, that is a horizontal stretch of a half. You don't have to flip it. There's no interpretation like that involved. That's only when you're looking at a transformation equation. Okay, so describe, oh look, it's 1/2 x. Describe the transformations on y equals f of x if it produces the following image point. So xy maps to 1/2 x minus 4, negative 3y plus 1. Pause me and write that down yourself. You should be writing 1, 2, 3, 4, 5 statements. And your statements are, we have a horizontal stretch by a factor of a half about the y-axis, a vertical stretch by a factor of 3 about the x-axis, a vertical reflection about the x-axis, and a horizontal translation 4 units left, vertical translation 1 unit up. Okay. Okay. If f of x is translated to y equals f of x minus 4 minus 3, then the range of the transformed graph. Well, here's what I need you to see right away. Like, let's play the multiple choice game here. I'm talking about range. Well, if I'm talking about range, I don't care about the x minus 4 at all, right? I only care that I'm moving this 3 down. So my original point was at -4, 1. If I take 1 and move it down 3, where am I going to end up? I'm going to end up at y is less than -2. Okay. All right. The graphs of y equals f of x and its transformation, y equals g of x, are given. The equation of h of x could be given by, now I love this question. Pause me and try it yourself before you see me do it. Okay. Here's what I need you to see. First of all, we look at the orientation of the graph. Well, actually, we could look at width of the graph first, because the width and the height, if they change, that tells me a stretch has occurred, okay? But in this one, they didn't change, so no stretches have occurred, and I'm kind of playing the multiple choice game at the moment, where I'm looking at A to D, and none of them talked about stretches, right? So I know I can ignore stretches right now. Orientation of the graphs, though, I do know that there's been a horizontal reflection, because the orientation of f of x, you can see, has been flipped this way, okay? Okay, then if I do the horizontal reflection, this point here is going to end up right there. And this point here is going to end up right there. And this point here is going to end up at +6. So that would look like this right now. Okay, so then I say, okay, that's not where I want to end up. I want to end up right there. So I slide my way over. So I have to go 1, 2 to the right, and 1, 2, 3 up. So I would want you comfortable to say that I have to do a horizontal reflection, I have to do a horizontal translation 2 units right, and a vertical translation 3 units up. It's important that when you're doing these multiple choice type questions, like kids get all excited that, oh, it's multiple choice, my answer's in front of me. Yes, your answer's in front of you, but so are the 3 most common mistakes that a student's going to make, right? So when you're doing these things, the best thing to do is to not look at these answers at all, and just see if you can figure it out without those answers, then get your answer and compare. Because if you did that, you would have come up with this equation first. G of x equals negative x minus 2 and then plus 3. And then you would have seen, oh, okay, A, B, C, and D don't have those double set of brackets. So I'm going to have to distribute my negative sign. That would be negative x plus 2, and that means that the answer is C. Okay. The problem is a lot of kids would look at a question like this and they'd answer B because they saw the negative x and they saw the 2 to the right and they weren't thinking about the fact that that's not in fully factored form. Okay, remember we talked about that a couple questions ago, and I absolutely promise you this will come up a few times on your diploma. You can't read those transformations unless you're in factored form. Okay. Okay, the point Q, which is 6, 12, is on the graph of y equals f of x. The point that corresponds to Q on the graph represented by y plus 1 equals f of 1 over 3x can be written in the form AB, comma CD, where AB and CD are each digits of a 2-digit number. The values of A, B, C, and D are. Okay, so I just have to figure out what the new points are. Well, let's talk about x. What did I do to x? Well, so x got replaced with 1/3 x, which means that's a horizontal stretch of 3. So that means I'm going to multiply all my x values by 3. So 6 times 3 is going to turn out to be 18. So that's my AB. That means A is 1 and B is 8. Okay, because it said AB was a two-digit number. Okay, then what did I do to y? Well, I have y replaced with y plus 1. Now, if you want to write that as y equals first, sure, you'll see your k value is negative 1. Okay, which means I'm going down 1. So the 12 is going to become 11. So that's my value for C and D is 11, which means my numeric response question would be 1811. That would be the answer to the question. Okay, so 1 goes in the first box, 8 second box, and so on. Okay, the point 8, negative 2 is on the graph of y equals f of x and is mapped onto the image point negative 1, 4. And that's on the graph of y equals g of x. By the transformation, g of x equals negative 2 f of b x plus 3. What is the value of b? Okay, so if I'm looking for b, I really only care about horizontal items right now. So I care that 8 is turning into negative 1. And the way 8, let me just circle that for you so you see what I'm doing. 8 is turning into negative 1. Okay, and the way that's happening is I'm going to multiply it by 1 over b, and I'm going to subtract 3. Okay, because I know I have a horizontal stretch of 1 over b, and I know I'm going 3 to the left. Okay, so I set up a little equation where I know that if I stick in my original 8 value into here, and I multiply it by 1 over b, and I subtract 3, I should end up with the new x value, which is negative 1. Well, that's just an equation I can solve for b now with. Okay, so now I'll add 3 to both sides, and b ends up being 4. Okay, now we had set this up already to exactly tell me what the value of b is. So don't get yourself kind of caught on a downward spiral here and say the answer is 1 over 4. The value of b is 4, and that's all they asked for. If they said, what's the horizontal stretch? Then you'd have to say the horizontal stretch is 1 over 4, but the value of b is 4, okay? So question 9 says a function is defined by h of x equals 2 bracket x plus 1 all squared minus 5. State the equation of the inverse of a function. Now, when we deal with inverses, we're going to change that h of x to y, and we're just going to switch the where x and y are. So y will become x and x will become y. Okay, so I switched my h of x to y, and now I'm going to switch my x and y. Now I need to isolate for y. So I'm going to add 5 to both sides. I'm going to divide both sides by 2, and then I'll square root both sides. It's super important when you go to square root both sides. Remember that when you're taking the square root, it could be positive or negative. So you have to have your plus or minus, excuse me, in the square root there. Okay. So I end up with plus or minus the root of x plus 5 over 2. If you wanted to write inside that radicand, if you wanted to write that as x over 2 plus 5 over 2, that's fine too. That doesn't really matter. And then you want to subtract 1. Now, this is not a function. So I want you to notice that I wrote my answer as y subscript 2. I can't call this h to the negative 1 of x because that's reserved only for if the inverse is a function. Okay, so if the inverse was a function, I would have written it as h to the negative 1 of x, but because the inverse is not a function here, I have written it as y subscript 2. And the reason I stuck the 2 there is because I wanted to distinguish it that it was not the same y as this y right here, right? So that's why I stuck the y to the 2 there, or y subscript 2 there, I should say. Okay? Okay, a function is defined, so same function. Now, a possible restriction on the domain of h of x so that the inverse is also a function. Well, what I would want you to be comfortable with here is that this is a quadratic. This is a parabola. I know I have a vertex of, sorry, I'm just switching colors here. I know I have a vertex of -1, -5, and I know I open up. So my graph looks something like that, where this is -1, -5. Okay, so if I want to restrict the domain, what I want to do is I want to only say a piece of this domain so that the piece that I take, if I took the inverse of that, it would be a function. Okay, right now, if I took the inverse of that, I would get something that looks like this. I would have -5, -5, -1. So it would look something like that, right? Okay, and so I don't want that because that's not a function. So what I do, and here's the thing I want, like many of you may be listening to this and saying, dude, it's just greater than -1 or less than -1. And you're right, that is the answer, but I want to have a little conversation here instead, because it doesn't have to be cut at the vertex, okay? Don't assume that it must be cut at the vertex. I could cut right here. Let's say that was +1. I could say x is greater than 1, okay? That would be totally okay because x is greater than 1 just gives me this section up here. And if I took the inverse of that, that would be a function. That would be totally fine. The problem is I can't say x is less than 1 there because I'd get that change of direction. It's this change of direction right here that's problematic. If your restricted domain includes that change of direction, then the inverse won't be a function. Okay? So that's why we often say the easiest thing to do is just to cut at the vertex. Because if I cut at the vertex, it doesn't matter whether I'm saying greater than or less than, there won't be a change of direction there. There will be questions you get asked though where it has multiple minimum and maximum values. So you can't just say you're going to cut at the vertex, I guess is kind of the point I wanted to make there. So the answer to this guy though, all things being equal, was x is greater than -1. Okay. All right, so let's take that just a layer deeper based on the conversation we just had. What is a possible restriction on this domain? Well, x is greater than 0. If I was to look at that, let me just put a line there for a sec to help you out. If I showed you x is greater than 0, I'd be looking at everything over here. Well, that includes this guy and this guy. Both of those are changes of direction, so the inverse of that wouldn't be a function. If I did x is less than 5, 1, 2, 3, 4, 5. So I cut at the vertex there, but when I go less than 5, I have still this change of direction down here and this change of direction up there. So that wouldn't work. I could have done greater than 5. That would have been okay, but less than 5 doesn't work. Okay, -2 to 1. Well, -2 is right here and 1 is right here. That almost works, but I have this cute little change of direction right there, so that's not going to work. So then if I change that to -1 to 2, -1 to 2, there is definitely no change of direction in that little section. So the inverse of that little section would absolutely be a function. Okay, so the answer to that guy would be D. Okay, the function g of x equals 3x minus 7 undergoes several transformations to form a new function h of x, such that h of x is 2g of 3x minus 2 plus 5. State the equation in terms of, state the equation of h of x, sorry, in terms of x. This is a super important phrase to you. In terms of x. That means I don't want the transformational equation. Actually, I've already been given the transformational equation, right? The transformational equation was h of x equals 2g of 3x minus 2 plus 5. I want to take that and I want to take the original equation and I want to come up with the new equation that I could actually put into my graphing calculator and see the new picture of g of x after I do all those transformations to it, okay? Now, the way I do that is I say, okay, this is g of x, and this is g of x, right? The original g of x was 3x minus 7. So I'm going to take g of x, and I'm going to multiply it by 2, and I'm going to add 5 to the end of it. Okay, so think of it like this. Here's g of x. I'm going to multiply it by 2, and I'm going to add 5. Okay, but also what I'm doing is I'm replacing x. It doesn't say g of x anymore. It says g of 3 times x minus 2. Now I'm going to multiply the 3 there just so it's a little easier to do the math with. We don't need that many brackets there. That's 3x minus 6. So that's g of 3x minus 6, which means every time I see x, I have to replace it with 3x minus 6. If that's a g of 2, I'd replace x with 2. If it's a g of negative 5, I'd replace x with negative 5. So right now it's saying g of 3x minus 6. So I'm going to replace x with 3x minus 6. Okay, so it's 2 times g of x plus 5. And then the g of x is 3 times x, but I'm going to replace that x with 3x minus 6. Okay. Now, I did this in a couple steps just to show you how I was doing it. What I would caution you on is I wouldn't actually write this one down in your work. Okay, because technically 3x and 3 of 3x minus 6 is not the same thing. So this is not actually an equivalent guy. I would have gone right from this guy straight to him. Okay, I just put it there so that you could see what I was doing in a couple different steps. Okay, so now that I've done that, this is the equation I want. I just have to clean it up a little bit. So this 3 will get distributed. So that'll be 9x minus 18 and minus 7. And then negative 18 and negative 7 would be negative 25. Multiply everything by 2. And then I can take my negative 50 and add 5. So I get h of x equals 18x minus 45. So this dude is the result of taking this dude and doing all of that stuff to it. Okay, cool. Okay, consider the graph of y equals f of x shown below. The domain of the graph is x is a member of the reals, and the range of the graph is y is greater than negative 5, sorry. The graph is then transformed such that y equals 5 f of 2x. Which of the following statements is true of the graph of y equals 5 f of 2x? Now I'm doing both a horizontal and a vertical item here. I'm doing a horizontal stretch of 1/2. I'm doing a vertical stretch of 5. So that should affect both the domain and range. The trick to this guy, though, was in your domain. Your original domain is x as a member of the reals. Taking x as a member of the reals and multiplying it by 1/2 is still going to give you x as a member of the reals, right? Infinity times 1/2 is still infinity. So in this one, it's only the range that changes. Okay. Okay, this is a released item. That's why there's that big orange sticker there. So released items are items that actually have come from previous diplomas. I think when all is said and done, between the class examples that we do together and the extra practice that you do, if you do every question I give you, you'll have done, I think, 4 full diplomas of released items in there, plus other stuff. So I've given you lots. Okay, the graph of y equals f of x is shown. The graphs of y equals f of x and y equals 3 f of x intersect at. Well, when we're asking if they intersect, that's a fancy way of saying what's the invariant point. I've done a vertical stretch of 3 there. And so all the points would change, which means you really probably shouldn't intersect unless you were an invariant point. Now, I kind of want to have a little conversation there because you can intersect, 2 graphs can intersect and they not be invariant points. But the way this graph is set up, if I'm doing a vertical stretch of 3, all of these guys are going to be higher, right? Like this is going to end up looking like something like that. And so nothing else would intersect there. Now, I've also kind of just given the answer away. It would intersect at A because the value for Y at A is 0, and 0 times anything stays 0. So that's where my invariant point would be. Okay. Just get so excited. Okay, so just a couple things as we wrap this up to watch out for. Remember, I promise you this will happen on your diploma. Transformations cannot be read unless they are in factored form. So you have to take whatever that B value is and factor it out of the X minus C stuff. If you are building an equation from words or from a mapping rule, it's built in factored form already. Okay, so if I was just to list the transformations and ask you to build the equation, there'd already be 2 sets of brackets there. And then be careful with the words in terms of X and in terms of f of X. In terms of X means I want the actual equation that we're going to graph. In terms of f of X means I'm looking for that transformational equation. So there should be like a g of something on that side or an f of something on that side. That's it in terms of f of X. So that should be an f of something on that side. Okay. All right. So that is it for transformations. I will see you for polynomials is next, okay?